so I will put my next hat. So it's still the same hat of University of Oulu and Tampere University, but in this case, it is a work with other colleagues from University of Bergen, University of Nottingham in Malaysia, and Davide Hesbacca from Tampere University and Thomas from University of, I don't remember, in US. He was in Baylor, he moved last month. I don't remember the name of this university. By the way, today I'm going to present a literature review on unikernels. I guess several of you know what are unikernels. We heard already today, a couple of you mentioning them. How many never heard about unikernels? 1, 2. Well, that's a very good audience from this topic. So I can just briefly introduce for those of you who are, for these 2 people who don't know unikernels, why we need them. I think it's not bad to say that we need light containers. And one of the, in my previous presentation, I already told you, the checkpointing takes a lot of time. And why? Because Dockers are too heavy, are too huge. So if I want to transfer a Docker, it takes time. First to checkpoint, second to transfer. So it's a waste of energy. We need to find lightweight containers. And the unikernels are pretty lightweight. They can be a potential solution. Of course, there are other options. There are not just unikernels. In this work, we wanted to try to understand what are unikernels and why they are really needed. So what are unikernels? Now I'm going to read it. I know it's boring, but it's just to give a common framework to all of you guys. So it's a highly specialized single address space. So we have just one address space, differently from Docker. It's immutable, so you cannot change it. It's not like Docker that you can enter SSH and change it. No way. What you have is what it remains. It's lightweight image. So it links an application only with necessary libraries. So that means you cannot add anything that is not used at runtime. There are tricks, you might add them, but you are making a workaround for something that is not the nature of unikernels. And the libraries are loaded at compilation time. So differently from, let's say, differently from Docker, where the libraries are loaded directly in the Docker, and then you are moving the Docker with all the libraries. In unikernels, when you compile it, depending on the library that is actually used at compilation, the unikernel will import only those libraries who are needed. So you can already see it's way lightweight because there is not useless libraries. There are 2 unikernels. One is language-based. So that means a unikernel that can be used just for a specific programming language. And the other one who is like POSIX, that means you have a single address space, a single privilege level, but you can use, of course, a different language from this point of view. Again, this was not meant to give you the complete introduction to unikernel. This will take probably a couple of hours traditional lecture. To make another small comparison, you know, with virtual machine, we have this abstraction where we have hardware, hypervisor, and on top of that, we have each virtual machine who has the guest operating system, libraries, and software. With containers, we have the hardware, the host operating system that can be whatever, Windows, Linux, the container engine, Docker container engine in that case, and then on top, the container engine, we have system libraries and the software that you are going to run. Multiple containers, same engine, multiple containers. In unikernels, instead, you have the hardware, the hypervisor, similar to virtual machines, but we don't have the engine directly. We have just system libraries and target software. I mean, this lightens a little bit, but the most important part is that libraries are loaded at runtime. So that's the very big change. So what did we do in this work? We wanted to understand what are the reasons why people are moving to unikernels. It is not just, I mean, we are expecting already that it's not just because they are lightweight. There might be any other reasons. What are the benefits that the people encounter when they migrate to unikernels? What the difference between reason and benefits? The reason is why I moved to. The benefit is what I actually experienced them. So, you know, a lot of people adopt a new technology. We got the same feeling when we investigated microservices, we investigated serverless. A lot of people migrated to microservices because they thought microservice would have saved the world. with microservice, you could have reduced anything, reduced cost, reduced maintenance. Then after 6 months, 1 year, they realized that probably it was not the best solution. So same with my Unikernels. I want to see if what is your expectation is actually met or not in the benefit. And then what are the major issues? Because whatever technological change has pros and of course do have cons. The silver bullet still doesn't exist. So we did the multivocal literature review. That's the classical process that we do in academia. For those who are not familiar, a multivocal is taking a voice from multiple sources of information. So we take peer review literature, that is the classical peer review literature, like journal papers, conference papers. Also, this workshop is peer review literature. And we took also what is called the gray literature. Gray literature is voice of everybody on internet. So we have blog posts, we have news, we have Medium posts, we have forums, you know, Quora, Reddit, all those type of information. It's a pretty standardized process. It's very strict. I will not go very in deep on the process, but it's just to give you an idea. We search for Unikernel, motivation, benefits, problems, issues, and operating system to see what was there on the market. Of course, as I said, I'm not going to enter into the details of the process. Just to give a very, very high-level overview, we search for all the sources, and then inside every single source, we did what is called the snowballing. So we search if the source was linking another interesting source that we did not consider. We review the papers all together using, let's say, multiple people reviewing the same sources, and then calculated what is called the inter-rated reliability. So that means if me and him is reading the same blog post, and we check if both extract the same information, if both agree on the same thing. I mean, we are humans. We can make mistake. And then we use this kind of coding system to extract all the information. I will skip for you all the boring methodological issues now. We found almost 600 results talking about that, of which 528 was excluded because of our inclusion-exclusion criteria. Of course, we excluded everything that was using Unikernel for something else. There were people using Unikernels for medicine, using for whatever other topic that is not related to what is the Unikernels that we know. And we finally included only 62 sources, not that many, of which 40, so 64% peer-reviewed literature and 22 gray literature. Of course, this required also screening of the quality of the source. We excluded any kind of promotional materials and so on and so forth. So let's go to the most interesting aspect. I know this table is very full of data, but it's very useful to see what are the technologies available now on the market. So just concentrate on the left side. So we have this list of Unikernel frameworks: Hermitax, Lupin Linux, Rampran, IncludeOS, MirageOS, OSDub, OSV, Rusty Hermit, Hermit Core, ClickOS, MiniOS, Ling, and HAL LVM. So this is this is the complete list of technology that we found from Unikernel side. Again, I know it's boring, but it gives you the complete idea. And most of them are target to a very, very specific software or hardware. So as you can see, a lot of them are target to KVM. Some are running on VirtualBox that I wouldn't consider a bad side running on VirtualBox. This is just an extra. So you can still run on KVM, ASAXi, but if you want to test it, you know, student or let's say toy project, you can still do it on VirtualBox. That's positive. You don't need to set up a complex system. Some of them are really tiny. I mean, 4 active contributors. The first 2 has only 4 active contributors. Honestly, I wouldn't rely on a technology that has only 4 contributors on GitHub. I would probably consider something more developed. Some of them has a last commit very, very old. I mean, they have 25 contributors like Rampran, but the last commit was on May 2020. So this one, December 2020, but future release. Instead, OSV is way more developed compared to others. I mean, the results of this work has been extracted 9-10 months ago. So something might have changed in the last 9-10 months. The world, I don't expect a complete revolution, but there might be other technology that came up in the last 10 months, or some of this might have revamped a little bit more. So in terms of results, why people are migrating to Unikernels? First, security. People want to have more secure systems, and they believe that Unikernel, since they are smaller and they rely directly on the hosting system, they don't need to manage all the security that usually Docker containers need to manage. So they say they have a smaller attack surface. Performance, obviously, they are smaller, they are faster, they take less resources. They want to have this supporting technology that is helping to build, especially edge computing, optimized resources similar to the performance. Service modularity. Honestly, I don't really understand. A lot of people say that using Unikernel, you can have a better modularity of your service. From a software engineering professor's side, I would say, why can't you do it in Docker? I mean, you can split a system into different containers independently if they are Docker or if they are not Docker. But I'm just reporting you blindly exactly what is mentioned in the literature. Then we have service isolation, of course, because Unikernels are very, very isolated, way more isolated than Docker containers. Cost, less resources, less resource consumption, less cost, of course, and personal motivation. And personal motivation means I want to follow the hype. I really love it. Let's see the benefits. People agree with performance. They confirm that performance are better. So performance gets to the first position. Resource optimization is also increased position. So they are really positive. But they expected to have a better security, but in fact, they found a lot of issues in security when using Unikernel. So they moved for your security, but actually didn't experience that much security. The reason is that the technology is still in a too early stage. There are a lot of security leaks at the moment in several Unikernel technologies. Probably in future, they will get better. We don't know. Depends what is going to be the technology that it will take traction, if any of those few that I listed will work or not. They have way better deployment approach. The reason for deployment is that it's the same for the offloading. Deployment means you need to transfer the data. It's smaller, it's faster, it's lightweight to deploy. So you can deploy way faster. If you have a heavyweight Docker container, it might take some time to deploy because it's heavy. If you have an extremely tiny lightweight, you can deploy in a few milliseconds. That's another reason. They have a lot of technologies. They say supporting technology went down because technology doesn't support that much. The libraries are not that easy to use, especially now something is not compatible, something is not really working. Yeah, they agree there is reduced cost. Someone still say that they appreciate the better modularity. Still, again, put in my head of professor, I don't really understand this point, but this is what people are reporting. Issues. Maturity is the first problem. So they are not yet mature. We hope in the next future they will get, or maybe another technology will just take over Unikernels. In terms of technologies, there is a problem of lack of multiprocessing. I don't know if you can read this text with this color. I read it. So there is lack of multiprocessing. So at the moment, you don't have multi-thread or multiprocessing in Unikernel supported. At least 10 months ago, none of them were able to do it. The development process is not that easy because there are some cumbersome hacks that you need to set up compared to Docker. And each of them, they do have their own small hacks that you need to do it. Vendor lock-in, obviously, that's obvious with any technology. Once you started, you are like marrying a technology and it's heavy and expensive to move to another one. But this is common from whatever technology you choose, you will have the same issue. Compatibility follows the previous that I mentioned. So they are not very compatible. A lot of libraries are not running, something they are not compiling yet. The reason is that they don't have a hosting operating system. I mean, Docker, well, you can install whatever Linux distribution on Docker and run it, so you have compatibility almost with everything. almost. Here, no, you need to have the host operating system that is helping you, and that is not running on Unikernels. There are no management platform. At the moment, the management is really poor, at least 10 months ago. Security is not that easy to manage. They were hoping to have security by default. People hope, yes, I use Unikernels, so I'm going to be extremely secure. Nobody can enter, nobody can attack. Well, then they realize there are a lot of security threats open on Unikernels, again, because of maturity, not because the technology is not supporting it. And finally, you know, resource utilization, unexpectedly, in several cases, was way higher than Docker containers. So the throughput was higher than containers, and the transmission performance was lower because of higher CPU usage, unexpectedly. So to almost conclude, there are a few open questions. The first, security. We don't know if they will fix or if security threats are still not clear. It is also not clear when Unikernels should be used, except for the fact that we expect to have a lower footprint, but then we see that the communication throughput is higher. So it's lower to transmit the data. So to transmit, to move, to do offloading is lightweight. But then to run computation is not that lightweight. So there are those issues now. And the management is still not clear. We still don't know if we need a separate management layer, but then we go back to Docker style. So this is not what we want. We still don't know if we want a Kubernetes-like platform. There is no Kubernetes-like platform for orchestrate them. In conclusion, so they are, of course, a promising technology, something new on the market. And I think we need to give a chance to this technology to see if it can be really mainstream or if any other technology might take over them. There are multiple implementations. We still don't know what's good and what's bad. Okay, some of them are a little more used, but we are not talking about millions of users. We are talking about 40, 50. So we are still in a handful of users or a bit more. They're in early development stage, and at the moment, they are not easy and to use and manage. Now, the end of my presentation, the conclusion is not don't use Unikernel. The conclusion is evaluate them, consider when they're useful for your project, and you can use that list to have an idea of what are the different technology and compare yourself. And in the paper, of course, there are way more comparison information. The presentation was not long enough to give you all the details. Okay, thank you.
Thank you so much. Yeah.
Yes.
There's some questions.
Which first?
So how are you now going to next prove that these are useful?
Sorry, too?
How are you now going to prove that these are useful indeed?
Well,
do you plan to
this is not my task. I mean, usually, let's say our research process is always first step, whenever there is new technology, we check motivations, benefit, and issues. Then if they really works, if there is really strong motivation and adoption, the next step is to work on patterns, or let's say best practices. So try to elicit from company best practices on how to use and how not to use. And finally, if the technology gets mainstream, we develop adoption frameworks. Still, we are in the very early stage of this long research process. Yes.
I have a brief question. Assuming that the gray literature reflects the perspective of developers, is there, if you remember, is there any Unikernel framework that is favored by the gray literature?
Well, yeah. The one that seems to be favored is Mirage OS. At least there are way more opinion. But my opinion is that it is because of the 52 contributors. Well, okay. Include OS has 60 contributors. That's similar or comparable. But Mirage OS was, in my opinion, the one that had more traction or more positive comments on gray literature.
Okay, thank you. Thank you.
I mean, I think your as a sales pitch, the best that we can say probably is wait and see. Okay, fair enough. But I was wondering, because I think that containerization and cloud computing is about distributed programming, not any programming.
Yeah.
So do you have some idea, some measure of how many of the users of these Unikernels, they use them in clusters, right? Because you said there's no orchestration, so I have to do it by hand, but maybe I can customize it more. Maybe it's a good thing in some circles.
Yeah.
So how distributed are the typical applications that go to Unikernels?
The few examples that we found, they are not mentioning about, let's say, Kubernetes-like, because it doesn't exist, but they develop their own customized solution. So they develop their own edge systems where they are doing like some offloading, but there is not really that much orchestration. It is simply, for example, they do it for weather forecastation. They have those weather forecastation that they do some data collection, then they have an edge node that collects the data, aggregate them, and then send pre-compute in some way, we don't know how, and then send it to another station. So this type of stuff has been developed, custom made, of course, but there is no orchestration. Yep. Yep. Yeah. Yeah, absolutely. Absolutely. This technology. Absolutely. Absolutely. Yeah. I wouldn't say then wait and see, but I would say, I mean, we are all researchers. So my suggestion is try them and try them in comparison with other technologies. So do some study, do benchmarks, and let's try to shed some light on the technology